Construction Studies with Mr. Claffey. We're doing question 5 2019, and it's safe to say 2020 was probably the worst year in living memory. Onwards and upwards 2021. So if you feel like you've missed out from last year, a company called Tuition Farm are doing live online grinds. So if you feel like you've missed out this year, which understandably you have, tuitionfarm.ie. So today's question is on the U value. So you may have heard the quote before: nothing is certain in this world except for death and taxes. You may add on U value as question 5 on the construction paper. So why pick the U value question? Well, it's a guarantee every single year, no waffle involved, quicker than most questions, say on average 20 to 25 minutes depending on the question, easy for a higher level math student. You can know if your answer is correct, well, almost know if it's correct or not. So every building material has a given heat resistance. Thankfully, we don't have to memorize the table as they always give it to us in the question. To do this question, we are usually given a component, a wall or a floor, and the material elements which make up that component. Example, concrete blocks, insulation, plasterboard. So here we have a wall with high heat, high U value. High U value means a lot of heat loss. So as you can see, not much insulation. A low U value means less heat loss. So a low U value, which we try and aim for under 1. U values measure how effective a material or component is as an insulator. The lower the U value is, the better material is as heat insulator. So we can see straw bale very low, and then the concrete block beside it is actually higher. So the straw bale would be a better heat insulator, surprisingly, but it is. So when we talk about the U value of a particular component of a building, such as a wall, roof, or a window, we are describing how well or badly that component transmits heat from inside to the outside. So here we have the inside of a building. Even though it says outer wall, that was my mistake. And going through the material element, internal surface, brick, and then insulation to the external surface. Okay, so brief overview of 2019 question 5. It's very similar to every other year of U values, and the notes and the question are both downloadable in the bottom in the comments section or in the info section of the video. So as you can see, it was poorly designed, as most of the houses in the 1990s were. We have our external render, the outside. We have our concrete block outer leaf. We have our clear cavity, 50 mil. We have our polystyrene insulation, 50 mil. We have our concrete block inner leaf, 100 mil, and our internal plaster, which you can't see there, but it's just on the inside. So this is a pretty standard U value question, which we will just use our table for. So the table is the same as it always is. It's a 5x5 grid, so I do 5 centimeters by 5 units, and the reason it's 5 centimeters is just because it's handy to remember 5 by 5. And in those grids are the material element, conductivity, resistivity, thickness in meters, and the overall resistance. With that overall resistance, which is the resistance total, we divide 1 by the resistance total, which gives us our U value, which you'll see later. So part B is using the U value from earlier. So whatever U value you got, you're just going to put it in, and we're going to use the trap method. So trap divided by calorific value of oil multiplied by 1000. And part C, we are given the thermal conductivity, and they want to make this house passive standard. So what's the new thickness of the insulation that they're going to add to bring it up to this passive standard? And as we can see, it's more than 50, looks like minimum double, so it's going to be about 100. So if your answer isn't a bit over 100, there's something gone wrong. Step 1, write out the formula. So the formula for resistance is thickness in meters multiplied by the resistivity, and thickness in meters divided by conductivity. Step 2 is to draw our 5 by 5 block. So just 5 centimeters to make it convenient for an exam, and 5 of them. So 5 by 5, it's just easy to remember, and I have changed the colours of each one to make it all nice and neat in your notes, and also nice and easy to follow for the YouTube video. So material elements. First thing we're going to do is write in material elements, and then we are going to tick off all the elements as they appear. So the external surface, the render, block outer, the clear cavity, poly insulation, concrete block inner, and the internal plaster. And just to double check then, I also tick it on the list down below. Not necessary, but it's nice to do a double check all the same. So check. And we're going to put in the conductivity, K, small k. So just wherever you see a small k, conductivity of concrete block, external, put it in, 1.44, insulation 0.037, and block 1.44 again. As you can see, the low U value is the insulation, which is obviously what we want. So resistivity of the external render and the internal plaster, they've just given us those small R values. I've highlighted the K and the R value, so we're going to insert them in. Internal plaster and the external render, so 2.17 and 6.250. And thickness, but it's in meters, which is probably the most crucial part for this table. Extremely important. And I'm going to zoom in on thickness in millimeters, and we're going to convert it to meters. So divide by 1000. I have the calculator beside me, but you can do 3 dots to the left. It's pretty handy, but I wouldn't risk it in the exam. So you should be doing this yourself, not copying my answers, because that's no use to anybody. But there are the answers, and I am going to then bring them down onto my thickness table and put in the information. So that's my thickness done. My overall resistance, we get this by using the formula earlier. So resistivity multiplied by the thickness, 2.17 multiplied by 0.16, and then we're going to do the same for resistivity by thickness again. So 6.250 multiplied by 0.012, that'll give us our answer of 0.075. And the other part of the formula, which is our thickness divided by our conductivity, to get the R. So 0.100 divided by 1.44 and 0.050 divided by 0.037, and it's just a case of filling in. We add up all the resistance totals, so RT is resistance total, and we're going to add them all up now. As you can see that I'm doing on the calculator, you should be doing it yourself, but just check mine to double check. And we get an answer of 1.939. So, like the earlier formula, 1 divided by the resistance total will give us the U value. So 1 divided by 1.939 will give us 0.5157. So I'm going to round that up to 0.516. So with that, we can go on to part B. Using the U value, 0.516, calculate the cost of heat lost annually through this wall. So step 1 is our trap. So find our trap, which is time, rate, area, and price. And step 2 is using the trap, multiply each of the elements of the trap and divide it by cal multiplied by 1000. So the calorific value of oil multiplied by 1000. I'm just going to write out time in seconds, rate, use the U value multiplied by the temperature difference, area, and the price. The price is given to us at 94 cents. The area is 135 meters squared. No calculations there. The U value we know, and the temperature difference is 19 minus 5, giving us 14, 7.224. Time in seconds is probably the trickiest part of this. So 60 seconds in a minute, 60 minutes in an hour. There are 9 hours that it's on for. So multiply by 9. How many days in a week? 7. And how many weeks do they want? 36. So 60 seconds multiplied by 60 minutes multiplied by 9 hours multiplied by 7 days and multiplied by 36 weeks. Should give us 8,164,800 seconds. So after that, we use our trap formula and we put it all in. So we're going to be multiplying the time, the rate, the area, the price all over the calorific value of oil, which they've given to us as 37,350 multiplied by 1000. So we come up with a huge number here. I think it's I'm not even going to try that, to be honest. And multiply the bottom by 1000, which you could do without the calculator, but maybe don't risk it. And it will give you an overall value of €240. And the answer is obviously going to be price, because they're asking for cost. So just always make sure you match what they're asking for. So €240. Upgrade the heat properties of the house. And as we know, passive houses are extremely well insulated, so it's definitely going to be more than that 50. It looks double, if not treble. So your answer should be somewhere between over 100 mil and 150 mil. That's a good guesstimate. So here we have our old U value of 0.516 and the new U value of 0.15 with that extra piece insulation which we don't know the thickness of. To find the thickness, we first need to find the resistance difference, so R, between two values. So we get our two values and we need to find R. So it's 1 divided by resistance total, which we've done already in this question. It's 0.516, and 1 divided by 0.15. We use our calculator, gets our answer 1.938, and on the other side we get 6.666. So as expected, our new resistance is high and the old one is low. So the resistance difference is caused by the insulation, the extra insulation we've added. So if we find the difference in the resistance, we know that this is caused by the insulation. So we can then use our 5x5 U value table. So I've just gone ahead and copied that table. You wouldn't need to draw it out again. I've drawn it out again just to make it clearer. So the expanded polystyrene, we've got the conductivity given to us in the question at 0.031, and we've just found resistance above 4.729, and we need the thickness. So we're going to use the formula again, and we just have to manipulate the formula slightly. So resistance equals thickness divided by K, conductivity, and we are going to fill it in without changing it. So the resistance is 4.727 equals the thickness over 0.031, and we're going to multiply that out. So 4.727 multiplied by 0.031 equals 0.146. So that is 0.147, corrected 3 decimal places, meters. And you could leave it like that, or you could change it back to millimeters, which is 147 millimeters, which is within the range that we guessed at the start. Stay safe.